So, we will discuss some other passive concepts actually, which you can add to the building. Some are very easily, some can be done very easily. For example, I was mentioning about texture other day, that can be done very easily. You can choose the surface finish or the color such that the alpha value is minimal, right. So, those are simple things to be done, but there could be something little bit more complex thing also can be done. So, this is what I was mentioning other day, surface texture and color, right. Short wave absorptivity should be as low as possible, long wave emissivity should be as high as possible, right. So, for white washed surface, alpha is very small, 0.4 or so, quite small, and epsilon is 0.9. So, now if there is a paint which it performs even better than this, that would be a favorable thing. Intense shading due to projection is possible, less absorption. So, as I was saying, perhaps I have a diagram, no, not here, maybe somewhere there is a diagram, I will come back to this once I will come back later on. This I will come back later on. Yeah, this is the kind of texture. For example, if I have a surface which is textured like this, some projections and then that means it is something like this, it is something like this, I am just making it, or simply put some stones here, finished stones. They do of course grit finish, which has got other problems. What they do is they make the sand mortar, put a plaster and give a acid wash, so that aggregate gets exposed. Plaster with slightly larger size aggregates also involved in that is around 5 mm. Now, if it is too porous, it might actually allow water to get trapped, and if it is over a structural member like reinforced concrete member, holding the water would mean that in the long term there is a possibility of deterioration, corrosion and all that. So, one has to be careful about using those, but if you have a brick surface and you texture it, put a mortar, but put also stones on top of it. So, this will be a textured surface, and such textured surface, some portion, this portion solar radiation will be received, this portion will not receive solar radiation, right, because it will be blocked, this portion will not receive, this is the portion it will, only some portion here in this hole. I mean, if I exaggerate it something like this, so sun's ray will not be receiving in this area, right. Of course, when it is inclined like this, depending upon the sun's orientation, but while emitting radiation, whole of the surface will be involved. Effective surface area is much larger for emission or convection, but for absorption effective surface area is less. So, textured surfaces can be very useful, they can reduce the amount of solar radiation intake, it can actually reduce. So, texture, as I said, texture and like texture intense shading due to projection, less absorption, that is possible, and for emission surface area is increased. So, therefore, there is a possibility. We can make earth shelter structure, we will come to that, basement and similar ones, we will come to that sometime later on. Now, you see it is a wall, in fact, for solar gain developed in France, right, Trombe-Michael wall. I am sure that must be used in quite a bit, I am not sure whether they use it these days or not, but this is a concept that was developed there. You have a glazing. So, you have a glazing that is glass. As I mentioned earlier, glass is transparent to solar radiation, but it is opaque to long wave radiation. So, you can use lot of glass in such areas, such climatic situations, subtropical condition, because it will allow a lot of heat to come in and get trapped, or for that matter cold climatic zone in Indian subcontinent, you can use them there as well. So, the problem is when you have glass, it absorbs the radiation all right, but since it is thin, it's useful only at that period of time. But cold daytime when the sun is available, it's not really worthwhile to use the sun only at that period of time when sun is available outside, right. You should be able to use it when it becomes cold in the night, store it for some period of time. So, this is what we call indirect gain into this space. So, you have a glazing, the solar radiation fall onto this glass, and there is a wall which has got high thermal capacity, even if it is a brickwork or something like that. And I mean, this is, of course, you have to have some holes in them through a damper which can close or open, right. So, what will happen is this portion, it will get heated up, and this will also heat up this wall. The solar radiation will pass through this and it will heat up the wall as well, and this air here also will get heated up. So, hot air will have a tendency to move like this, and cold air from the room will, right. And this, since this gets heated up, it stores up the heat and it can supply it later also, rather than, in fact, as I was telling you, in European scenario, I am not sure about the France part of it, because I was there, I visited only for a short period of time, but let us say bordering France, Switzerland, that Geneva and those areas, they have bright sunshine in summer, and they have big glass windows and all that. And if you are sitting in the afternoon, I mean the day is very long in summer. So, sun will set around 9 p.m. and maybe 10, sometime around that time. So, 7, 8 p.m. the west facing, if it is glass, southwest facing, then it absorbs a lot of heat, and in fact, it becomes pretty warm. And you feel a discomfort because of the heat, because they do not have fans. It is not designed for for heating, external heating. It is all designed to keep it warm during winter, because the winter is dominant scenario there. So, temperature within the space can go pretty high, right. Now, in such situation, storing that heat would be useful. Store it and maybe use it in the night when things cooler. Night means it is a small night still, and if it is sunny like Ladakh, which is sunny, even in winter it is quite a bit of sunny, it would be a good thing to store that heat and use it in the night. Ladakh is cold and sunny. In fact, what is said is that if you stand and on the south facing, let us say east, so on your right is the south and left is the north, so you can have a sunburnt on this side and frostbite on the other side, because there is all snow around. So, it is very sunny, but a lot of snow, and in fact, this is if you by chance visit even place like Rotang Pass and similar ones, you will get sunburnt in summer time if you are going, because a lot of reflection from the snow. So, wherever sun is there on that side, I mean if you have a bald head like me and you are on that side, you might get a lot of black spots on your head and faces and all that, one side of the face. So, but this is useful, you can store that heat and use it in the later part of the day. So, this is called, that is why it is called indirect gain. This is called indirect gain, thermal storage wall. So, that is indirect gain, right. Now, well, people have tried this kind of thing, put water drums, because why? Water has got high thermal capacity, water has got high thermal capacity. So, but these are not very practical things really, making brickwork is fine. Water will have other kind of problems if it is tropical scenario, and you might have a summer scenario. Of course, tropical scenario you do not do that, you might have mosquitoes also. So, if it is a little bit open and so on. But however, this is the idea. This is called a trans wall. What is this actually? What is the problem with this kind of wall? It will also block the light. Direct solar radiation all right, but block also the light. But supposing I put something like this, a trans wall, where I have got water, and this is a semi-transparent, it is not a slab, is not the right terminology, actually semi-transparent panel, a translucent panel, right, made of let us say perspex sheet, polymers, plastic translucent polymers. So, what will happen? The sun's ray will pass through this, the light will pass through it, but this will be also stored in the water, and light will pass. So, this is transparent, light will pass and it will act like the same wall that we are talking about. But again, this is complicated construction actually. I am not sure how much it is feasible, it can be a one time demonstration sort of thing, but in functional building using these are not very easy. While first one is not that difficult to utilize, the other ones are not very easy. You can, this is again indirect gain, this is the space which get directly heated, then there is a wall, this is a buffer space, this gets heated up and then it heats up this space. So, swing will be less in this one, otherwise this will have high swing. When solar radiation is being received, its temperature will go high up, and later on in the night part when temperature is down, the swing will be pretty high, swing will be small here. So, this could be your living space, mass is somewhere here. So, this sort of concepts can be utilized. And isolated gain is what we use in flat plate collector, or today you have got all those photovoltaic panels, they actually collect, and there of course they generate electricity. This one of the good old days, they will simply heat up the water. So, this is a collector which will receive the, which will receive the sun's radiation, and the water, because of thermosiphonic effect, warm water due to convection will have a tendency to move up, and here you have a kind of a heat storage, some mass where hot water will be stored, right, and the cold water, hot water is at the top. This heat will be dissipated outside or used for some other purpose, maybe for swimming pool, partially cooling, heating the swimming pool water or similar sort of thing, circulation, in using together the building, hot water services in the building, and the cold water then. So, this is called isolated gain. So, first one was indirect gain, so if you have seen the direct gain, indirect gain. So, this is actually, if you leave the damper out, I will have, wall out, I will have direct gain, this is indirect gain, this is also all indirect gain, and this is direct gain in this zone, indirect gain in here, and this is isolated gain, somewhere away I am doing it. So, this kind of concepts can be utilized in some manner. Shading already we talked about, these are passive features, shading already I have given you the concepts, I think I will not mention this any further. Texture also I have mentioned to you. Then people thought that they can do some sort of shading in the roof, right, shading in the roof. So, for example, some sort of concrete shade. So, this solar radiation will be blocked, but this again feasibility is big question, feasibility of this kind of concepts, extra cost will be involved. But there are people who tried this out and put them in books. So, I thought I should tell you some things, you never know where someone will innovate and do what. So, just giving you introduction to all these ones, right. So, this will actually block the sun's radiation, this will block the sun's radiation, and night this will actually radiate to outside, this will get heated up during daytime anyway, night actually this will radiate out, this will get cooled faster. So, some radiation to the shade will occur, and roof shading can, because we have been talking about shading the windows, but somebody feels like shading the roof, that also is a possibility, that also is a possibility, right. You can put some plantation there, roof garden, you have to be careful, because lot of waterproofing becomes very important in such areas, because if you have done roof garden, you can do it, you can maintain it, and it will cool, because there will be lot of evaporation from the plants, and obviously it will do cooling. And if you do it slightly at higher level with a gap, right, this will shade, or something like this, plant starts from here, it occupies more area at the top, your flower pots and things like that, or maybe even vegetables or whatever it is. So, the top would allow sun's radiation, but block part of it, it will do a shading, but lot of evaporation. So, this cooling is possible, but you have to design the system, issues of protecting the structural members, waterproofing, drainage of water, this becomes important, and most important, water should be available to you. because there's some places in tropical areas, dry areas, rainfall being very low, the water availability might be questioned. So but roof shading is possible. Some people thought they will use inverted earthen pots, but in both the cases actually access to the roof is maybe there, but it will not be utilized, because you can't utilize the roof for any other purpose. And if you put this also, this is an earthen pots, earthen pots, right, water jars, earthen water jars, inverted, and this will do what? This will almost act like an insulation, because there are a lot of air voids, large air voids within the pot. So it will act like an insulation. Large surface area is a kind of texturing. So receiving area, solar radiation receiving area will be relatively effectively less, and emitting area is high, right, or convective losses can be over from the large. It will actually protect the roof from solar radiation. So this is, but again breaking this, it might get broken, maintenance is not one has to be careful. So but it can, somebody can use it like this, somebody can use like this, right. Saucers, earthen saucers, inverted earthen saucers, that might be a more feasible one, earthen made of what you call vitrified, like vitrified clay product, right, burnt clay products. So burnt clay earthen saucer, if you put it inverted at the rooftop, smaller ones, they might still be more useful than this kind of a okay, one can innovate on them, right. So these are some of them. Roof shading by some canvas or something. During daytime you block it, you can roll it up, as if you can roll it up. So night you open it up. Daytime you put it, solar radiation will be blocked. Night you open it up. Now that becomes, you have to, the occupant has to be now trained, and their involvement also comes into picture in this kind of scenarios, right. So reflective canvas you can put it, it can be white painted so that it reflects quite a bit, but then somebody has to do this job every day, and night remove it. Night you don't remove it, could be blocking the heat radiation going out. So one has to be careful about that. Roof ponds, some people also, there are a lot of research paper came on that in 1980s. So you put a water, or put wet gunny bags, or put gunny bags on top of the roof and then wet them every day. But again, waterproofing and all those issues will be there. You have to have water available, otherwise there is a problem. In fact, this is traditional in northern India. They will wash the balconies and those areas every summer afternoon, right. So actually it's meant for evaporative cooling also. So this is one thing. You might make a water pond and cover it up with a transparent cover and some movable insulation, right. So this is your bags of water could be there, or water pond could be there, and then transparent cover through which light will come, and movable insulation. Daytime you put in the insulation, night you remove it. So therefore this will store the heat, this water will store the heat, will not allow it to go in, but night it will radiate back, and also part of it will be inside the room. If it is a hot dry desert climate, it might be fairly useful thing, or hot dry desert scenario, but then you got to have water, that is, and then waterproofing of the roof, this also So all kind of things, water bags here, flooded, water bags filled with their so absorb solar radiation. This is the concrete structural slab, summer daytime. This same thing is shown in different manner with all the mechanism that's possible. Now remember, all of this will involve additional cost, and it has to be justified, including the life cycle cost, the maintenance cost. So this is what it is. The other kind of thing is, you have instead of that wall I was talking about, now you have something in the roof itself. You had a wall, the transparent polythene or something which will allow sun's radiation to come in, and you have sort of holes here in the slab. So hot air gets heated up here, wind can also facilitate this cooling in the night, and daytime whatever solar radiation is received, this is actually trapped here, this is stored here, and then later on in the night it actually transfers. Hot air, warm air from the room can come in the night, and then cool air from this one, because night this will radiate to the sky and cool it down. The air here will be cooler, and then this circulation can cool in the night easily. So radiative cooling is possible. You can have something like this. In the night radiation occurs, the cool air will come here, move through this, through the courtyard. So courtyard plan can be effective, because in the night it can do easy cooling. Cool air here, because this would radiate out, cool air here will have a tendency to move like this, and you have openings here, openings there, it will actually cool faster in the night. And you can have a water pond, which is normally done. If you have seen houses in northern India, Haryana, part of Haryana, Rajasthan, etc., I am not sure, in Punjab perhaps also is there, you will find that they have courtyard type of plan. In traditional housing you will find courtyard type of plans, and you will have somewhere they will be washing their utensils. So sort of a cistern would be there, and it actually also helps in radiative cooling, This is used in Middle East quite a bit. This is used in Middle East quite a bit. So this is a wind tower, right? So basically, stack effect. Depending upon stack effect is what? Rho GH is the pressure at this point. So depending upon the height, we will discuss this sometime when we talk of ventilation. Rho GH. Now here rho outside and rho inside would be different, right, depending upon the outside air condition, because this will receive, if it receives radiation and gets heated up, the inside air will be also heated up, inside air also will be heated up, right. So inside air also will get heated up. So if it is rho 1 minus rho 2 into G into H, G into H, H is the height. Now if the inside air is warm, what will happen? Rho is less. If inside air is, if it is warm, then rho is less. So rho GH at this point of outside, rho GH is higher, inside air is rho is less, so the pressure here is less, so there will be a flow along this direction. When outside air is warm and inside air is still cool, the flow will be in the reverse direction. In other words, so during day and night, this feature, the air movement will be different. So for example, night, of course, both wind condition, if there is an external wind, it will all change. External wind, it will all change. Daytime, what happens is, outside air is, it tends to become warmer. Inside it requires some time to get heated up, this chimney sort of thing, or the tower, it would require some time to heat it up. So if outside air is warmer, then density rho GH here is, rho 2 will be less here, so pressure, the movement will be along this direction. So dark line shows airflow during daytime, right, dark line shows airflow during daytime. The inside is cool, it is yet to get heated up, outside air gets heated up. So what will happen, the outside hot air enters here and it becomes cool, and then moves out through these areas and cools the room. So for example, this is one floor, this is another floor, it will cool down both the floors. In the night what will happen, because by the daytime, evening, this has all got heated up, and inside the stack also, or inside the tower, the air is also quite warm compared to the outside, which is now cooled down. So the whole thing is that pressure here will be more, the direction of the movement. So dotted line shows the movement in the night time. So the cool air from outside enters there, then cool air from outside enters here and gets out, taking the heat from the wall itself, and in the process eventually by the morning the wall and the inside air is all cool, outside starts heating up. So this tower can be effectively utilized. If there is a wind, it will depend on along the windward direction, the pressure tends to, supposing this is the wind direction, this will actually disturb the whole flow, because there are of course all four openings. There are 4 openings here, there are 4 openings, there is no opening here, there is some opening there, some opening there. Now if there is a windward direction is this, actually it will push. So it will add during daytime, but night it will actually oppose the movement. So actually what we call neutral plane shifts, neutral plane, you know, where the pressure is 0. Outside and inside pressure is same, that shifts because of the wind direction. So there is no wind condition, this will get disturbed. So this is wind tower scenario, this is wind tower scenario, right, wind tower scenario. And you can actually use below the ground similar tower, right. If there is a wind blowing, it will take it in this manner, this is your space to be utilized, basement. And you see the one thing, temperature below the ground is usually constant. Below 4 meter down you go, it remains close to 20 degrees centigrade, 20 degrees centigrade. So the temperature in summer, surface will be something like this, here it is 20, right, some constant, below some 4-5 meter height, 4 to 5 meter height, it will not change. And you go in winter, if you look at it winter, in winter if you look at it, in winter it would be other round. This is cold, but here it is still same. You know, this might be 4, this must be 40. This is still remains same. So you can make use the ground. This is forcing the air to move through below the ground and using that for, you know, thermal comfort inside this. You might have openings here which will allow flow, but you can even make a fan to drive this, but then you got to add the cost because, you know, all the rodents might make their holes and homes there, all these issues you will look into. So this feasibility of these are questionable, but while you know, they used the thermal what they call is, you know, geothermal heat, that has been utilized in cities. For example, at the aquifer level the temperature remains by and large constant. So top you might have snow or it has cooled down, but aquifer water temperature is relatively high. Canada, they have actually used cities to really heat up. Yeah. So this is another concept using earth tunnel, and this is again used in Middle East, Iran, etc., quite a bit. You have a, you know, like living room, air circulation, you have a tower here, openings here at the top, crown you will have openings. So same sort of a, this height is important here now. There is an entry, here is an entry, this height, so same stack effect will be there, rho GH, outside air and inside air, but here the openings are at the crown actually, openings are at the crown. So this height h will dictate how much flow would take place, same daytime and nighttime circulation, similar manner as I discussed earlier. And you might have a foundation and air pool and a pool of water here for evaporative cooling, might use. So this kind of things are used in Middle East traditionally. Together with this, there is a cistern, there is a wind tower, and you know, like make this wind to flow. This is all possible. I think we'll just quickly break and look into a few of the system that is there. So coming back to this, then there are similar other concepts like radiation trap. So this one is, you know, direct radiation comes in here. Now this is the, you know, the summer, this is movable, So this there are sort of airflow pipes sort of is possible. I mean, basically keeping hole there. This is the blackened surface which can receive radiation during winter. So during winter time this is open, this gets radiation. In summer time you close this down, and that sort of thing. And you know, like, so cold air summer flow, warm air winter flow, etc. The insulation is there. This is an insulation. So summer when it comes down, you will have, it will block and is also an insulation, will not allow heat to come in. Winter you open it up, solar radiation comes in. So, you can trap the radiation during winter, summer you may allow. So, this is another also similar. Now, this is a simple wall. This is a simple wall. This wall has, you see the same wall, you have to actually use it, user occupant has to make make use of this actually. It is something like this, you have a thick portion here, thick wall, and there is a thin leaf outside, and this there is a opening, there are slits here which you can close or open. So, during daytime this you close. So, it will act like an air gap cavity wall. So, no sun radiation can come in, unvented cavity, there is no vent. Night you open this up. So, what will happen, daytime this portion would have got heated up anyway, it is received radiation. Night you want to open it up, cool air will move along this direction and take away the heat from the room as well. So, cool it faster. So, this is called very thermal. This was one of the features put in those buildings, but you have to maintain them. Maintenance is an issue. Similarly, unvented, similarly if it is a winter condition, that was for the summer. In winter condition what you want? Daytime you have, this is a leaf and this is the wall. Daytime allow the radiation to fall in this will heat it up. So, hot air moves in along this direction into the room. Night you close it so that it becomes an insulation, whatever it has gone in cannot go out. So, the same wall can be used, for example, south facing wall where you receive lot of radiation in summer, I mean winter, sorry, not in summer, might use this kind of thing. So, depending upon the situation, orientation, etc., if you summer time you should be able to open this, right, and winter time you should be able to open this. So, there will be kind of movable slits available actually which you can open, or flaps which you can open or close, and this very thermal can be made use for summer or winter time scenario. Earth, as I said, 4 degrees, like if you go 4 meter below, temperature do not change. So, anything below basement is always comfortable, but issues are other issues. You normally have waterproofing, I mean water seepage problem in this one. So, unless you have designed the system properly, and fire protection, basement fire protection, it has to have sprinklers and similar sort of thing, right. So, those becomes also important issue. So, earth-bound structures, because below the earth temperature is nearly constant, below some degrees in some 4-5 meters, at the top whatever changes are occurring, bottom temperature do not change that much. So, in summer it remains cool, in winter it actually remains warm compared to outside. And if you have glass or something like that, other features you can always mix up. This is the earth, this is the earth. So, partially it can be sheltered through earth and all that. So, I think these are some of those passive features I'd like to introduce to you. Next time I think I will talk about some of the overall design scenario, then look into ventilation.